Now see exercise 2.4. Question number 1. Test whether the following functions are increasing or decreasing. So when we call this f of x is increasing, that we discussed in previous lecture, when f dash of x is greater than 0 and f dash of x is less than 0, then the function is decreasing. So with the help of this concept, we test whether the given function is increasing or decreasing for x belongs to R here. So for that we have to differentiate this function, write in solution f of x is equal to x cube minus 6x square plus 12x minus 16, differentiate with respect to x. So derivative of f of x, we write f dash of x, derivative of first term, that is derivative of x cube, we write 3x square, derivative of second term, we write 6 into derivative of x square is twice x, so write 6 into twice x plus 12 into derivative of x with respect to x is 1, derivative of minus 16 which is single constant, its derivative is 0. So write this in proper way, 3x square minus 6 into 2 12, so write 12x plus 12 into 1 12. So here f dash of x is equal to 3x square minus 12x plus 12. So from each term we can take 3 common here, so write 3 in bracket x square minus 4x plus 4. If you observe the bracket, this is square of x minus 2, so we write here 3 in bracket x minus 2 its square. Now we have to check f dash of x is greater than 0 or less than 0. So for that here condition is provided, x belongs to R. So x belongs to R, that means we have to take the value from this set of real numbers. So for our convenience we take here a real line, so 0 1 2 minus 1 minus 2, and from this we select the value for checking f dash of x greater than 0 or less than 0. Now if you observe here, when we replace this x by 2, we get 2 minus 2 which is 0. So here f dash of x equals to 0, that means we have to exclude x equals to 2. That means we have to minus these 2 from this set for checking the increasing or decreasing function, because we get 2 minus 2 0. So except 2 we check next value. So when we take x is equals to 1, here we use here one value, that is trial and error method. We check this, we write here x minus 2 its bracket square. So when x is equals to 1, we get here 1 minus 2 its square. So 1 minus 2 is minus 1, minus 1 square we get plus 1. When we take x is equals to minus 1, then here we get x minus 2 bracket square as minus 1 minus 2 its square. So we get here minus 1 minus 2 which is minus 3 its square, so which is plus 9. That means here if we get the value of here bracket as greater than 0 or less than 0, then here we multiply by 3. So we check the value of bracket only, because value of 3 is fixed. So when we replace this x by plus 1, we get the value of this bracket as 1. So 3 into 1 we get 3 which is greater than 0. When we take x equals to minus 1, that case we get value of this bracket as 9. So 3 into 9 we get 27. That means for positive and negative value we get the value of f dash of x which is greater than 0. So we write here, therefore f dash of x greater than 0 for x not equals to 2, x belongs to R. Means excluding x equals to 2, we get this function f of x as the increasing function. So write here f dash of x greater than 0. So we write here f of x is increasing function, x belongs to R minus 2, that means excluding 2, this f of x is increasing. Now see second sub question. F of x equals to 2 minus 3x plus 3x square minus x cube. X belongs to R. So in solution we write f of x is equals to 2 minus 3x plus 3x square minus x cube, which is given function. We have to check increasing or decreasing, so we have to differentiate this with respect to x for finding f dash of x. So differentiate with respect to x, so write a derivative of f of x as f dash of x, then derivative of 2, which is single constant, its derivative is 0, minus derivative of 3x, so we find derivative of x. So write minus 3 into 1 plus 3 into derivative of x square, which is 2x, minus derivative of x cube, which is 3x square. Now 0 minus 3 into 1 we write minus 3, then 3 into 2 we write here 6 into x, 6x, minus 3 into x square we write as it is. Now we write this in descending order, so write this value of x square first, so write minus 3x square plus 6x minus 3. So we take minus 3 common, so write here minus 3 in bracket, x square minus 2x plus 1. So see here minus 3 into x square we get minus 3x square, minus minus get plus 3 into 2 6, so plus 6x, minus 3 into plus 1 we get minus 3, that means we have to take minus 3 common. Now this is square of x minus 1, so we write this x square minus 2x plus 1 as x minus 1 bracket square. So see here f dash of x is equals to minus 3 into x minus 1 bracket square, that means this f dash of x is greater than 0 when we get x minus 1 as negative value, and this f dash of x is less than 0 when we get x minus 1 as positive value. So we check for this x minus 1 only, we have to check for x belongs to R. So here if you observe, when we replace this x by 1 we get 1 minus 1 as 0, so excluding 1 we check this x minus 1 is either positive or negative. So see here f dash of x is equals to minus 3 into x minus 1 bracket square. Now we check for x is equals to 2. So for x equals to 2 we get here f dash of 2 is equals to minus 3 into 2 minus 1 is 1, so 1 square, which is equals to minus 3. Therefore f dash of 2 less than 0. Now we check for x is equals to minus 2. When we write here when x is equals to minus 2, here we get f dash of x, f dash of minus 2 is equals to minus 3 into, here we replace this x by minus 2, we get here minus 2 minus 1 its square, that is minus 3 into minus 3 its square, so minus 3 into square of minus 3 is plus 9, which is equals to minus 27. That means when we take x equals to plus value, then we get the f dash of x less than 0. When we take x equals to minus 2, in that case also we get f dash of x less than 0. So we write here f dash of minus 2 less than 0. In all cases for positive and negative we get f dash of x less than 0. So here we say therefore f dash of x less than 0 for x belongs to R minus 1. That means excluding 1 we get f dash of x less than 0. Therefore f of x is decreasing for x belongs to R minus 1. Sub question third. Here function is f of x equals to x minus 1 by x. X belongs to R and x not equals to 0. So this x not equals to 0 for this second term, that is 1 upon 0. We know that 1 upon 0 we get infinity, so we cannot define this function. So here condition is provided for x not equals to 0. That means for x belonging to R, we have to check this function is increasing or decreasing. So for that we differentiate the given function. So right here in solution given function f of x is equal to x minus 1 by x. So differentiate this function with respect to x. Derivative of f of x, we get f dash of x. Derivative of first term minus derivative of second term. Derivative of x with respect to x, we get 1 minus derivative of 1 upon x is minus 1 by x square. So we write this as minus minus plus 1 plus 1 upon x square. We simplify this. So for that we have to cross multiply. We get here x square plus 1 upon x square. Therefore, f dash of x is equal to x square plus 1 upon x square. Now we have to check for x belongs to R and for x not equal to 0. So we take some values for checking f dash of x is greater than 0 or less than 0. So here variable x has square. So for negative value also we get here positive value. So we write, or you can check here, f dash of x is equal to x square plus 1 upon x square. So for x is equal to plus 1, you can check 1 square is 1 plus 1 upon 1, which is 2 by 1, which is equal to 2, which is greater than 0. So similarly for x is equal to minus 1, you can find f dash of x is equal to minus 1 square, we get plus 1, so 1 plus 1 upon minus 1 square 1, we get 1, so 2 upon 1 equals to 2. That is similarly we can take for x equals to 2, x equals to minus 2, we get f dash of x always greater than 0, which is greater than 0. Therefore f dash of x greater than 0. Therefore f dash of x greater than 0 for x belongs to R, x not equal to 0. So from this we say f of x is increasing. Therefore f of x is increasing for x belongs to R and x not equals to 0.